question 3. So given this, we've got to show this. So we start off by using these two trig identities which we are given. This is in the formula booklet. So we're replacing cos x plus 50 with this. So this, the x plus 50, just becomes this with an x and a 50. So that's this bit in red. Similarly, with the sign bracket 2 values, we're replacing it with this. That's the bit in pink. Now, so we then just do the claw on the left hand side, gives us this. Now the key bit, I think if you look ahead to what we're aiming for, we're just dealing with the angle 40. So we're okay where we've got our 40s, but we really want to take these 50s out. So if you think about a right angled triangle with angle 40 and 50, our sin of 50 is the same as our cos of 40. Okay, our sin of 50, opposite over hypotenuse, is the same ratio as our cos of 40, adjacent over hypotenuse, and similarly cos 50, adjacent over hypotenuse, is the same as sin 40, opposite over hypotenuse. So these are interchangeable, so we can replace wherever we see a 50, we can go and replace it with the appropriate 40. So that's what I've done in this line here. You'll now see that we've just got sin x cos 40, that's what we've got here, sin x cos 40, cos x sin 40, cos x sin 40. So we just choose to take this away from both sides, giving us this equaling 0. I've then just gone and added 3 sin x cos 40 to get this. So in a way I could have done that. That's probably one extra step there thinking about it. I could have just left that where it was and just taken this over to this side. That would have cut out the in-between step. Anyway, you get from there to there. Now at this point, remember what I'm aiming for. I'm really aiming for tans, which is sin over cos. So thinking about what was going to start that happening, I choose to divide through by cos x cos 40. Okay, so on this side that eliminates my cos x, but so I have a cos 40 in my denominator, so sin 40 over cos 40, and over here that eliminates my cos 40, but I have a cos x in my denominator. So make sure that you're happy that when you have this over this and this over this, you get this. So sin over cos is of course tan, so this is tan 40 equals 3 lots of tan x. Divide by 3, we get a third of tan 40 equaling tan x as required. Now for part B, hence we've been asked to solve this. Well, as always with the hence question, you solve the equivalent. So we won't solve this within this range. We'll solve this within the same range. So we're solving tan 2 theta equals a third tan 40, because looking at this we can see that our 2 theta is our x. Our 2 theta is our x. Here's our x, so our 2 theta is our x in here. So tan 2 theta equals a third tan 40. So we just right hand side we can solve using our calculator. We get this. Now using our C2 skills, just be careful you're going to pick up all the values. So let capital X equal 2 theta, and therefore change your boundaries, your limits, from not 0 to 360 but twice this, 0 to 720. So we're going to substitute in, we're going to solve tan x equaling 0.2797. We inverse tan this to get our first solution of 15.626. Now then, using our all silver toy cars, if we just go between 0 and 720, our values come here at 15, all the way around here, which is 180 plus the 15, that's a 195, 360 plus the 15, that's the 375, and 360 plus another 180 plus that 15 gives us a 555.6. Now that's all our capital X values, so we just need to return it to theta. To get from x to theta, we divide by 2, so we halve each of these 4 values to give us our 4 final solutions.